great tool that we can use to understand X and Y variables and start, understanding the relationship between them, then is the cause and effect diagram. So don't mess up the cause and effect diagram with the cause and effect matrix. Okay, so what did I say? We're going to look at the cause and effect matrix. Okay, the cause and effect diagram is that fishbone diagram or Ishikawa diagram, and we're going to look at that later on. The cause and effect matrix is the one that we're going to look at today. Now, I hope I didn't mix them up. Maybe. Okay, and that's it. And we're going to do an exercise in class about this. But basically here, you have the process steps, you have process inputs, and on here in the columns, you're going to use your Y variables. Okay, so you can put your quality and say here quality, on-time delivery, or productivity, cost, whatever the Y variables are in the project. You have to have a scale from 1 to 10 for each one of them, so you can compare them to say that, for our project, cost would be a lot more important than on-time delivery, so we get cost 10 and on-time delivery is 6. So those numbers is just to have a comparison between them. You're saying that 10 is a lot more important than 6. A lot more, no, you're quantifying that actually, right? So here we put the Y variables, here we put the score of each one comparing to each other. And here we put the process steps and inputs. And what you're going to fill here when one matches the other is how those inputs impact on that performance metric, right? So, for example, the workers, let's say we're looking at a restaurant, the workers' training impact the quality of the product? It does, right? So works training has a big impact on the quality of the product because if they're not trained well, they can screw up, can do a mess, they can burn the kitchen, whatever it is, right? But the workers' training impact on inventory? Probably not, right? They're not the ones ordering the items. Maybe they're messing up some stuff, but not much, right? So you can match the input with the performance metrics and say which one makes more sense. Usually we're going to use a scale from 0, 1, 3, and 9 for this interaction. And then what you do is you just multiply that input, let's say, by each one of those weighted values for the key requirements, the Y variables, and add them up, and then you have a sum product here and total at the end. Okay? So let's say that, workers training had a 10 and a 6, and then you put, a 1 and a 9, right? So you have 1 times 10 plus 9 times 6. So you multiply that number by the weighted value plus that number times the weighted value to have the total for the row, and then you do for each one of the rows to identify which input is the most important one, right? So you can order them from higher to lower, so you understand what are the kind of the key inputs, and those are the ones that you need to collect data from, right? Those are the ones that you need to spend a lot of time looking at when you get into the analyze phase, because they are the ones that are contributing more to the Y variables. Okay, does that make sense? We're going to do an exercise in class, and I know that will make a lot more sense. So another concept before we get into the data world is going to be tough word. Operational definition. So operational definition is sometimes, people think that that's not important, it's a lot of bureaucracy, blah, blah, blah. But that's actually very important. Basically defining all the acronyms and all the concepts that we're going to use in a project. So if you guys did internships or visit a company and start talking to people that are explaining their job, you're going to find a lot of acronyms. I think maybe BMW is the queen of all acronyms because their acronyms are actually in German. So I did, project with BMW for about 3 years, and you have to learn words in German and then acronyms that you have no idea what they mean because they are in German, right? But any company used a lot of acronyms, and that's their own kind of language thing, and maybe they think it's cool or not, I don't know. And we need to create operational definitions when we're doing these projects because we need to tell them that we know what they meant by this, right? So it's a way that we define the key terms that we're using in the project. So we know that we are speaking the same language, right? So like a dictionary, right? So just an example of problem that might occur is okay. Let's say that I want to have a calculation of the cavity fill time, right? And I have a group of students that go there and start collecting data. But the question is, when do I start collecting the data about cavity fill, and when did I finish? When cavity fill begins and when cavity fills finish. So if you look at this process, we have initial examination, full examination, and then we have cavity palpation, prepare room, fill cavity, brush and floss, and then go. Right? So you can say, what do you guys think? When do they start? It could start when actually only this process cavity fills happen. It could be only the time of the process, but you can say, no, if your cavity palpation, that's already cavity fill. So we actually need to start counting time here from here. So you can generate some questions and doubts. It's the same thing of the numbers. Remember we did like the exercise that you guys put numbers there, and we saw that if you use a term that's qualitative, people will have a different impression. That's the same thing with operational definitions. We need to define them really well. Usually we create a slide which on a storyboard, right, that have all the definition. There's tons and tons of terms that I learn every project. This is one example of a capstone project. We collected FedEx data for thousands and thousands and thousands of shipments, and they had different ways to send things. I didn't know that there was 3, 6, 7, 8, 9, 10, 11 ways of sending something on FedEx, and there is. So they can do all this, and we had data, and we had to understand what are those codes, right? So a lot of codes, a lot of acronym happen on those kind of operational definition basis.